Welcome to Electronics Excel. So, we are into this basic electronics lecture series, and today the topic of discussion is the introduction to rectifier. Okay, so rectifier we will note that it is a circuit that converts from AC to DC. Okay, but the output of a rectifier it is not pure DC. Okay, so that is why we need several components. Okay, so basically we'll see what are the several components used for producing a constant DC supply. Okay, so let us get into the details. So rectifier. So for almost all electronic that is the equipments. Okay, so DC power supply is required. Okay, so for this purpose we have used that is the dry cells and batteries. Okay, but using the dry cells and batteries, some advantage is that they are portable and ripple free. Okay, so they are ripple free and the portable. Okay, ripple means the AC components are called ripples. Okay, so in a uh, output, the AC component is superimposed with the DC. Okay, the AC components are the called the means ripples. Okay, so these are the advantage of using the means dry cell and battery, but the thing is that their voltages are low. Okay, and they need frequent replacement. Okay, and they are expensive. Okay, as compared to the conventional power supply. This is power supply. So that is why we need a circuit that converts from AC to DC. Okay, so that is why we have a DC power supply. DC power supply means that converts from AC to DC. Okay, so again in case of DC power supply, what we have now, there is a transformer. Okay, so the transformer basically it is a step down transformer. Okay, so we'll see in details. So there is a power transformer, then it is followed by the rectifier unit, then there is a filter, that is a smoothing filter, then there is a voltage regulator circuit. Okay, the output of voltage regulator circuit we can get the pure DC voltage. Okay, so we are giving the AC signal through the transformer, then we have a rectifier unit, then we have a filter circuit, then we have a voltage regulator circuit. Okay, so there are the four components. One is your transformer, rectifier, filter, and regulator. So all are put in the single unit. Okay, let us see the output of a DC power supply is provide the constant DC across the load. Okay, so we'll have the constant DC at the output of a that is the voltage regulator circuits. Okay, so let us see the circuit look like. So this is the circuit that convert from AC to DC. So we have a AC input signal that is passed through a transformer. Okay, then we have a rectifier circuit, then we have a filter circuit, then we have a voltage regulator. The output of a voltage regulator is a regulated DC power supply. This is the constant DC supply. Okay, so we'll see one by one what will be the output of a transformer, then the output of a rectifier, then we have a filter, then we have a voltage regulator. Okay, so let us see one by one. So first one is a transformer. So basically in this case we are stepping down the AC signal. Okay, as per the needs of the our devices. Okay, so at the input of a transformer you can see we have a 220 volt. This one is a 220 volt AC. So on the output of transformer, so basically what we are doing is that this is the DC signal. So which is step we have used the step down transformer. So that is the output again it is a 12 volt or 9 volt. Okay. So the output of a transformer it is we are using the step down transformer. The output is a DC, but it is a quite that is the low voltage, that is a 12 volt. So this is come across the rectifier. Okay, so again we can see the transformer it can have the safety considerations. Okay, it is providing the isolation from the main line. Okay, so that is also include the internal shielding, so prevent the unwanted electrical noise signal. Okay, or getting into the power line into the power supply. Okay, so these are the advantage of using the transformer. So basically we are using the transformer is a step down transformer. Okay, so usually it is stepping down the AC inputs voltages. Okay, then the output of this transformer is fed to the rectifier unit. Okay, so let us see what is the rectifier unit. So rectifier is a device which converts the sinusoidal AC voltage into the either positive or negative pulsating DC. So this is a pulsating DC. You are not getting the pure DC. Okay, some AC components are superimposed with this DC signal. Okay, So you can see this is the rectifier. So this is the output of a transformer. Okay. So which is your 12 volt. Okay. The output of a transformer is 12 volt. So that is the rectifier unit. You can see this is the positive pulsating DC. So these are the DC signal superimposed with the AC signal. You can see this is the output of a rectifier. So we can have the positive or negative pulsating DC. Okay. So this is the output of a rectifier unit circuit. Okay. So you can see the actually what we are using the rectifier. In the rectifier we are using the uh, diodes. Okay. So PN junction diodes when forward biased, we can see it is conducts the current, and practical does not conduct current when it is reverse biased. So this is are used for rectification purpose. So it will convert from AC to DC, but it is not means we are getting the pure DC or getting the pulsating DC in nature. Okay. The rectifier unit consists of a one diode and two diode folders. If there is a one diode, this is a half wave rectifier. If this is a 2 and 4 diode, this is a full wave rectifier. Okay. So the rectifier may be half wave or full wave. Full wave is of two types, that is center tape or bridge type. Okay. So this is the rectifier. So rectifier we are getting this type of signals are there. Okay. This is known as a pulsating DC signals. Okay. Now we have a filter circuit. The output of a rectifier is a filter circuit. The output rectifier that is the pulsating in nature. So it contains the, you can see, unwanted AC components. These are called ripples along with the DC components. Okay. So your filter circuit what will do? It will means filter out the AC component. You can see that that is why we are using this filter circuits. So it is filtering out the AC components for the rectifier output. Okay, that is why we are having the filter circuit. Okay. You can see this is filtering out the AC component. We will get this type of signals in the output of a filter circuit. The filter circuit consists of the means we have a capacitor, inductor, and resistors. Okay, this filter circuit consists of capacitor, resistor, and inductors. Okay, so it will passes the DC component and blocks the AC component of the rectifier output. So this is the uh, means working of a filter circuit, or you can see the job of the filter circuit is to pass the AC component, and it will block the DC components. Okay. Sorry, it will pass the DC components and it blocks the AC components. So because we are interested in the DC components only. Okay, so it will block the AC components and we will have the DC component at the output. Okay, so it is not the constant one. You can see the magnitude of output DC voltage may vary with the variation of input voltage and magnitude of the load current. So we are not getting the constant voltage at the output of a filter circuit. So that is why we have a voltage regulator that will provide you the constant DC voltage at the output. Okay. So this is the voltage regulator. The output of a filter circuit is fed to the voltage regulator. There we can get the pure DC signal. Okay. So this voltage regulator may have the general diode, discrete transistor, and integrated circuits. So at last we can get the pure DC. Okay. So this is how your works the means this voltage regulator circuit. So we have the main function is to provide the constant DC output voltage. Okay. So also it will reject any AC ripple voltages, and it is not removed. That is not removed by the filter circuit. Okay. So these are we are having the four components: transformer, then we have the rectifier, then we have a filter circuit. These are the voltage regulator. So these are the DC power supply circuits. So together it will have the we have means it will convert from that SC signal to the pure DC signals. Okay, the output of a voltage regulator will get the pure DC signal. Okay, this is how the your circuit works. Okay. So rectifier, it is actually converting the means output of a transformer, that is we have two 12 volt or 9 volt of AC signal that will convert to the means pulsating DC in the rectifier circuits. Okay. So rectifier circuit also we are not getting the pure DC. For that we are requiring a means filter circuit, then we have a voltage regulator circuit. And at the voltage regulator circuit we will get the pure DC signal. Okay. So these are our references. Okay. So thank you for watching this video. Okay. Have a nice day. If you have any doubt, please free to ask me in the comment section. Thank you. Okay.